Lesson 39, Function Pointers. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Function pointers are just pointers which point to functions instead of variables. However, function pointers are more conceptually difficult than normal data pointers. Here we have a program with two functions that print their own names, function 1 and function 2. In our main function, we declare a function pointer in this line. The syntax of function pointers is strange, and it takes a while to get comfortable with it, so we will cover a few more examples for clarification. Function pointers are typed based on the argument types that they take in and their return type. This function pointer can point to functions that take no arguments and return nothing or void. In other words, this function pointer can be set to point to functions of the type shown above. After the declaration, we assign our function pointer to point to function 1. Then we call function 1 via our function pointer. Next, we assign our function pointer to point to function 2 and call function 2 via our function pointer. If we execute the program, we see that function 1 and function 2 were both called and printed their names. The syntax that we have shown for function pointers is different than what we have used for data pointers. However, we can use the same syntax for assigning and dereferencing function pointers. Here's the same program that we have just had, except that we have removed the comments and changed the assignment and function call for function 2. When we assign our function pointer to point to function 2, we use the address of operator as we did for data pointers. Likewise, we use the asterisk to dereference the pointer and call function 2. Either of these alternatives can be used. However, we will typically use the first version since it is more commonly used. Executing the program, we see that it runs just as before. In this example, we have functions to add and multiply two doubles. In our main function, we declare a pointer to a function that takes two doubles and returns a double. Then we set the function pointer to point to our add and multiply functions and call them via the function pointer with the arguments 2 and 3. Executing the program, we get the sum and product as expected. We can also have arrays of function pointers. Here we replace our function pointer with an array of two function pointers and assign the first and second pointers to our add and multiply functions respectively. Next, we call the first and second function pointers. If we execute our program, we get the sum and product just as we did in our last program. Our last example used an array of function pointers. However, we cannot make arrays of functions, so it makes sense that the pointer arithmetic operations are not allowed for function pointers. This is yet another difference between data pointers and function pointers. To summarize the differences between data pointers and function pointers, we note that we can use the alternative syntax on function pointers, and we cannot use pointer arithmetic on function pointers. Function pointers come from C and predate C++. In C++, function pointers are largely unnecessary. However, the function pointer concept is extremely important in object-oriented programming, and we will use function pointers frequently in our OpenGL videos. One of the most common uses for function pointers in C is sorting an array of objects with the qsort function. This program demonstrates how to sort with the qsort function. The qsort function is in the C standard library and is documented in our reference pages. In the first line, we include C standard library. Then we define our coin class, which has the year and value in cents of each coin. Below this, we have two comparison functions. These functions will be used to sort an array of coins based on the year and value respectively. These functions return -1 if the first coin is less, 0 if they are equal, and 1 if the first coin is greater. In our main function, we declare an array of 5 coin objects and assign them values. Then we call the qsort function from the C standard library to sort the array by year. The first argument for qsort is the array to be sorted. The second argument is the number of elements in the array. The third argument is the size of each element, and the last argument is the comparison function of the type we created above. After we call the sort function, we output the sorted coins. Next, we call qsort to sort the coins by value using the compare by value function and output the coins again in a newly sorted order. Executing the program, We see that the sorting function that we pass in determines the sorted order. This concludes the lesson.